Welcome to Center for Agriculture Nanotechnology. Now I am going to explain about the instrumentation of transmission electron microscope. In this instrumentation, we are going to discuss about what is the principle, what are the different important parts of the transmission electron microscope, then how it works. So now let me explain what is the principle of transmission electron microscope. The principles of transmission electron microscope is when a beam of electrons interact with the sample, the electron will pass through the sample. While passing, the electrons will carry the information of the sample and at a nano level. Okay, so using this machine, so we can have the magnification of 6 lakhs time. Having that magnification, we can have the resolution of 0.1 nanometer. So it means that using this transmission electron microscope, so we can get the information at atomic level. Okay. Now let me explain what are the important components of the transmission electron microscope. So here we have 3 important component system. One is the electron column. The next important system is the sample. Means that the fluorescence screen. Next important one is that the EDAC cylinder. This electron column, we have set up electromagnetic lenses like condenser lenses, objective lenses. So after that we have the set of projective lenses, and this is called the goniometer. So through which we are going to keep the sample in the sample dies. The sample dies is in between the objective lens 1 and 2, and so through which we are going to keep the sample. And this is called fluorescence screen. So here in that screen the electrons will be projected, and the next this is called the camera. So the camera is used to capture the shadow image, and the camera is connected with the computer system. Okay, the computer system. So where we have the image. After recording the image will be appeared here, and this is called EDAC cylinder, and this cylinder is filled with liquid nitrogen. The purpose of liquid nitrogen is to keep the sample always cool. And next important thing is that here the electron column always should be kept under vacuum. So to avoid any dust material, if the dust material is here, that will hinder the electrons movement, so that the electron column always kept with the vacuum. In that cavity we are going to keep the copper grid, wherein we are going to keep the sample and the copper grid. So far we have seen what are the important components of the transmission electron microscope. Now we are going to see briefly about the instrumentation of TEM. So in case of instrumentation, first we have to prepare the sample. So we have to prepare the metal sample and we have to prepare the biological sample. In case of metal sample, we have to go for sonication, and in case of biological sample, we have to go for fixation. After that, we have to use the ultra microtome sectioning machine to get the sample at very thin size of about 50 to 100 nanometer. So after preparing the sample, we have to keep the sample in the sample arm. Then the sample arm has to be inserted like this through the goniometer, and the sample now will be fixed in the sample dies. So after keeping the sample, so we have to on the filament, switch on the filament. So after that we have to set the required parameters. It means that we have to set the vacuum and the other required parameters. So after that, now the beam will be projected over the fluorescence screen, and using this panel, so it means that the intensity panel, left and right panel, so we have to adjust the beam with, after capturing the image by the camera, now that signals will be transferred to the computer processor, where the processor will process the signals and the result will be appear like this. From this image we will get the information of the given sample at atomic level or nano level like this.